In this example, we want to find the surface area of the surface generated when the curve given by y equals square root of 5x minus x squared on the interval from 1 to 4 is revolved about the x-axis. So I've sketched the graph of the curve here. So this is y equals square root of 5x minus x squared. And then now if you revolve it around the x-axis, this is a sketch of what the surface looks like. So we want to try to compute the surface area of this surface here. So the surface area formula is given here. So the integral from a to b of 2 pi times f of x times the square root of 1 plus the quantity f prime of x squared. So to be able to set up the integral, we first need to take our given function and compute the derivative to be able to plug it into here. So let's take our function. So f of x is equal to, so let's rewrite it using fractional exponents. So let's rewrite it in the form 5x minus x squared to the 1/2. And then now to compute the derivative, we have to use the chain rule. So f prime of x, so first we take the derivative of the outside, so the 1/2 comes down. The inside stays the same, 5x minus x squared. Decrease the exponent by 1, so if I subtract 1 I get minus 1/2. Then times the derivative of the inside. The derivative of 5x is 5. And the derivative of x squared is 2x. So now let's rewrite this expression into easier to see form. So f prime of x. So this goes in the numerator, and then this part goes in the denominator because the exponent is negative. So it's equal to 5 minus 2x over 2 times 5x minus x squared raised to the 1/2 power. Okay, so now in the formula, I actually have to square this expression, so let's compute the square here. So f prime of x squared. So I have to square this whole thing, so the numerator gets squared. So 5 minus 2x, the quantity squared, over 4. So 2 squared is 4, and then if I square this thing, the exponent cancels out. So what's left over is 5x minus x squared. Okay, so now we're ready to set up the integral. So the integral is from 1 to 4. To pi, f of x is the function here, square root of 5x minus x squared. And then this expression is the square root of 1 plus this quantity here, which we've already computed over here. So let's just plug it in. So 5 minus 2x squared over 4 times 5x minus x squared. Okay, so this expression is fairly complicated, so let's try to simplify it before trying to compute the integral. So because both these things are under a square root, what I can do is I can combine them into a single square root and take this expression and multiply through to these two terms here. So if I do that, so actually I can pull out the 2 pi. Okay, so I'm taking this and I'm multiplying it through to everything here. So this expression times 1 gives you 5x minus x squared. And then if I multiply this expression by this fraction here, you can see that this cancels out with this part of the denominator. So what's left over is the quantity 5 minus 2x squared over 4. So again, this thing cancels out this thing. Okay, so now let's expand this to see if we can simplify it further. So this is 5x minus x squared. I FOIL the numerator out, plus 25 minus 20x plus 4x squared all over 4. And then I can divide everything by 4. So this is 2 pi, the integral from 1 to 4, square root of 5x minus x squared plus 25 over 4. So 20 divided by 4 is 5, so minus 5x. 4 divided by 4 is 1, so plus x squared dx. So now you can see that this cancels out with this cancels out with this, and all that's left is 25 over 4. The square root of 25 over 4 is just 5 halves. So this whole integral is actually fairly simple. So it becomes the integral from 1 to 4. So again, the square root of 25 over 4 is just 5 halves. And so now we're ready to integrate. So the antiderivative is 5 over 2x, evaluated from 1 to 4. So this is 2 pi times, if I plug in 4, I get 10. If I plug in 1, I get 5 halves. And so it's 2 pi times 15 over 2, or 15 pi. So the surface area of this region is 15 pi.